Hello everyone and welcome to lesson 5 of geometry. This is going to be proofs. This is going to be probably the hardest lesson out of all of them. And this and next week too. These next 2 weeks are going to be the hardest weeks with proofs. Now, basically you've probably even heard of proofs before from your friends or other people who've taken geometry before because they're infamously the worst parts of geometry. Now that I know more about proofs, I would say that they're not that bad, but they're certainly annoying. So here's what I'm going to say. Basically, if you want to do proofs, and like what are proofs, you need to know basically some of the things that we're trying to do here. So as an example, we use proofs to prove things in geometry. Some examples are proving that two triangles are congruent, proving that lines are perpendicular, proving that a line segment AB is the bisector of line segment CD. And it looks like for some reason all of my lines are off. That's going to be annoying, but whatever. Anyways, with A, B, and C, D, being bisectors, there's a lot of things you can prove. Basically, you can prove anything in geometry. And so here's an example of what a proof is going to look like. We're not going to get to this level today where you're building the entire proof from scratch. That's going to take many, many, many weeks before you get that good, like me. But what I will tell you is that we're going to basically play like a fill-in-the-blank kind of game today, and that's what we're going to be doing. So first of all, here's what we're looking at with this, okay? What I'm going to say is you're always given some information, like this piece of information right here, and then you have to prove something at the very end. So proving is like the very last step. We start with the givens. In other words, in this example, AE and BD are bisected each other at C. So what that means is that if AE is bisected at C, then what would we say, excuse me, what would we say about that? Look at the second line here. So the first statement, there's always a list of statements and then reasons. The first statement should always be your given. Always goes first, okay? The next statement is the definition of a bisector. In other words, see how we're saying AC and CE are congruent? That's like one tick mark here, one tick mark there. And then we say the same thing for BC and CD. Two tick marks there, two tick marks there. And again, the reason why we're saying this is because of the definition of bisector. It cuts something in half, if you remember. The next thing we can say is ACB and DCE are vertical angles, because just look at these angles. That would be this angle here and this angle here. They are vertical because they form at intersecting lines. And we remember from probably lesson 1 or lesson 2 that vertical angles are congruent, which is the very next point in this proof, that one right there. And then the next line, we say that the two triangles are congruent to each other because of SAS. This is why we spent so much time last week talking about the triangle congruency theorems. You've got SSS, SAS, AAS, and ASA. And remember, not SSA, because that spells a bad word backwards. But anyways, what we have here is a side, an angle, and a side for both. You've got side, angle, side for both, so that's why they're congruent. And then the very last step is something that I kind of touched on a little bit at the very end of last week, but there's this theorem called CP-CTC, which I'll get more into today, and ultimately we use this to prove that AB is congruent to DE, and that was the statement we wanted to prove in the first place, this statement right here. So I know this, it's still very confusing. It's a lot of stuff being thrown at you at once. You're probably thinking you're not going to be able to do this by the end of today. And you're partly right, because you're not going to be able to do this. But if you can do like half of this, that's all I'm asking of you. And the other thing I want to just throw a helpful hint out there. For basically all of the proofs today, the general strategy is saying prove the triangles are congruent first using SAS, SSS, AAS, or ASA. And then after that, use this new theorem we were going to learn today called CP-CTC to basically cover the prove statement. And with that, let's talk about the reasons that we need to know. This is your word bank. In other words, all of the problems today that we're doing today and on the homework are going to be from this list. And I'll even help guide you through these. For instance, given, this is always the first step no matter what, and it's only going to be the first step. Definition of congruence, you're going to use that whenever you say two things are equal to each other. Let me explain. Like if I say, for instance, AB equals 12 and CD equals 12? Well, because of the definition of congruence, we could say AB, line segment AB, is congruent to line segment CD. And maybe you're wondering when I'm supposed to use congruent and equal signs, or those lines above versus don't include the lines above. And I'm not going to talk too much about that today because we covered that in lesson 1. And since I record all these lessons, you can go back to lesson 1 and you can actually see what I'm talking about there with the notation. But all I'm saying is if two things are equal, then they're congruent. That's definition of congruence. Definition of bisect just means cut in half. Midpoint is an extremely similar concept. Both of these basically mean the same thing. It cuts it in half. Okay. Perpendicular lines form right angles. That's just, a true statement, and you're going to use that whenever you have perpendicular lines. Right angles are congruent. This is saying like two right angles are congruent. I'll even put a 2 in there. Two right angles are always congruent. Next reason, intersecting lines form vertical angles. Remember, these are lines like this. Those are congruent right there. And you could even say on the other sides, these angles are congruent as well. Then the next one we have is the definition of vertical angles, which is basically the exact same thing. It's slightly different. You'd use it. We'll get into when you use each one because it's very similar. Okay, the next one, vertical angles are congruent. Yeah, it sounds like we're saying the same thing 3 times. And I get that. But technically, these are the 3 statements, and they all have their unique use cases. And again, we'll talk about that. The last one are the triangle congruency theorems, which I've mentioned earlier. Remember, not SSA. That is not one of them. And then reflexive property. This is something that's interesting that we're going to be going over later in the lesson today. It's an interesting one. And then finally, the last one, CPCTC, which I'm going over right now. CPCTC is a long acronym that stands for Congruent Parts of Congruent Triangles Are Congruent. That's a tongue twister if I've ever seen one. And the good news is it's actually one of the most useful theorems in all of geometry, especially for proofs. So you're going to be using this like all the time, and you don't need to remember congruent parts of congruent triangles are congruent. You just need to remember CPCTC. Now, I'll admit, even that's hard to remember, but at least it's easier than the whole thing. So as an example of what congruent parts of congruent triangles are congruent means, I have 2 triangles right here, ABC and DEF, and I'm telling you they're congruent. If I tell you the triangles are congruent, then we know what that means. It means every side and every angle is congruent. Every side and every angle is congruent. That is some of the sloppiest handwriting I've ever seen in my life. I apologize. Every side and every angle is congruent, which means let's give a list of things that are congruent right over here. So you've got line segment AB is congruent to line segment DE, like that. We've got line segment BC is congruent to line segment EF, as you can see. And then we also have line segment AC is congruent to line segment DF. That's it for the sides. Now we have 3 angles that are congruent. We would say angle A is congruent to angle D. We would say angle B is congruent to angle E. And the last one, angle C, is congruent to angle F. And whoops, I missed the angle. And all 6 of these things are true if you say the triangles are congruent. And so that's basically what we're going to be doing here today, is we're going to be proving that basically the triangles are congruent, like by, for instance, using SSS, like every side is congruent, so therefore the triangles are congruent. And then you say CPCTC is the reason why angle D is congruent with angle A. And if that's confusing, don't worry, we're going to be doing like 6 examples today. So you'll get the hang of it after a while. Any questions on this first page? Okay, fantastic. Now we're actually going to be giving some proofs. So as you can see with these first ones, I give you the reasons on the right and I have the statements on the left. And so here's what I'm going to be saying. First of all, for the given information, that is what you always write on the left for the first statement. In other words, I need to write LK and JK are perpendicular. And yes, this is going to take a while and you probably don't have enough room. So if you want to abbreviate, that's fine. But LK and JK are perpendicular. Angle J is congruent to angle O. And then finally, line segment JK is congruent to line segment NO. And I know I'm like squeezing it in there, but that first one's just the given, okay? And remember, the given always goes first. Okay, so we have the givens written down. My advice to you is after you write down the givens, let's actually show them on the graph. Like for instance, LK and JK are perpendicular. Well, I don't have to show that on the triangles. Angle J is congruent to angle O. I can show that by giving one tick mark on each. Angle J congruent to angle O. And then I can say JK is congruent to NO by putting one tick mark between JK and NO like that. So this is all the things I know. Now I'm just going to, since I give us the reasons, and ultimately I'm trying to prove what? I'm trying to prove JL, this side right here, is congruent to MO, this side right here. Now obviously they look congruent, but that's not enough to actually say they're congruent. That's why I have proofs. So on the next reason, it says perpendicular lines form right angles. What would be the statement for that reason? Maybe this is confusing to you, but I'm going to tell you perpendicular lines form right angles is the reason to say that angles K and angle N are right angles. And how do I know that? Well, the reason tells me perpendicular lines form right angles. How do I know they're perpendicular? Because it says LK and JK are perpendicular, and it says MN and NO are perpendicular. So for that reason, I know perpendicular lines form right angles, and therefore angle K and angle N are right angles. So does that mean they're equal to each other or congruent? Not until the next statement. The next statement actually proves they're equal. And that is equal angles are congruent. They are equal to each other. So then I'm going to say angle K is now congruent to angle N. Now they're congruent. By the way, another reason I could have said, if I wanted to, I could have wrote instead right angles are congruent. That's the same thing. That's the same thing. So obviously I don't have to change the reason, leave that. I'm just saying this would also be accepted. Now for the next one, ASA theorem, that's the reason. And if I look at my triangles, it does look like I have an angle, a side, and an angle in that order on both. So what's the statement? Well, the statement is the triangles are congruent. In other words, triangle JKL is congruent to triangle ONM. And technically the order matters as long as you match up the vertices between these two triangles. They are congruent. And then the very last thing, once you prove that they're congruent, the triangles, you use CPCTC, and you can just abbreviate it like that, that's fine, to say the last statement, which should always be the proof statement. The proof statement should always go last, and that is line segment JL is congruent to line segment MO. Now I know that was a lot. Maybe it's not totally makes sense yet, but are there any questions for that first one? One thing I do want to say is that the order does not matter. In other words, you can write these in a number of different orders here. Yes. Go ahead. Question.
I kind of just joined late, so...
Yeah, so basically if you want to catch up, probably the best thing to do is just to watch the recording, honestly. But just to give you a quick recap, do you have the packet printed out in front of you?
Well, I've tactic... What?
Well, basically, if you have a packet or like an iPad or you're looking at this, like something like this, I just want to show you one quick thing. This is the word bank we're using today, and this is like the most important thing. So even if you want to take a picture of this on your phone, I don't care. But this is the word bank we're going to be using for all of the proofs we're doing today. And what are proofs? Proofs are just saying statements that are true, and you have to prove it using these like 5 or 6 lines of logic and reasoning in geometry.
Oh, okay.
And we're going to be using a lot of the stuff we talked about in the first few lessons. And that is basically to say that we're going to be using bisect, perpendicular. We're going to be talking about things being congruent, angles versus sides. We're going to be talking about all the different triangle congruency theorems. And yeah, it's a lot of fun. It's not, believe me. So anyways, we're on to number 2. Number 2, again, the very first statement should always be the given information, which I'm just going to rewrite here. Wx and yz intersect at O. That's the first statement. Also under given, you can have more than one given. I have 3 givens here. The next given is angle Z is congruent to angle W. And then the last given is line segment WY is congruent to line segment ZX. Okay. So now I'm going to mark that on my diagram. So first of all, the fact that they intersect at point O, I don't need to say anything about that. I don't need to indicate that. What I am going to say is angle Z and angle W are congruent. So 1 tick mark there, 1 tick mark there. And then we also say WY, which is right here, is congruent to ZX, which is down here. And that's what we know so far. And by the way, you cannot say WX, or should I say, you cannot say WO is congruent to OX like we did the last one, because that had the word bisect or even midpoint would work. Do you see the word bisect or midpoint in the givens here? No, we do not. So in other words, the 2 black lines I have highlighted are not congruent yet. I can't say that. Instead, I look at my next reason, and it says definition of vertical angles. That makes me think back to what vertical angles are, which are basically 2 angles that intersect at a point, like point O, for instance. What I'm saying is that angle O here and angle O here are congruent because they're vertical angles. Although, even though I just said that in one sentence, I can't do that in one line of a proof. That would technically be skipping a line. So in other words, what goes in for definition of vertical angles? The statement would be this. And I'm going to write it in a different color because this is getting cramped. I would say angle WOY is not congruent, sorry. WOY and angle ZOX, both of those are vertical angles. That is my statement. I'm saying they're vertical angles. Then in the next line, I can say they're congruent because the reason vertical angles are congruent. So now I can say WOY is congruent to angle ZOX. Any questions there? Okay, good. Now the very last thing second to last thing, is we see it says AAS as the reason. Well, let me look at my triangle. Looks like I have angle here, side here. Same is true for the other triangle, so yes, they are congruent. And what's the statement? The statement is that the triangles are congruent. So in other words, triangle WYO, and there's quite a few different ways you can call these triangles names, but triangle WYO is congruent to triangle ZXO. And there we go. There's the next congruency statement. And then the last thing we say, because we usually end on CPCTC, is to say that these angles right here, angle X, must be congruent to angle Y, and the reason for that would be because of CPCTC. So the very last line is the prove statement. Angle X is congruent to angle Y. Any questions on that one? Okay, great. Moving on. So you're going to see in the next problem that we're not always given the reason. As a matter of fact, once you get really good at these, you're going to be doing all the statements and all the reasons without me telling you. Now, of course, we're definitely not there yet, but for now, let's start working on the reasons, which in my opinion, the reasons are harder than the statements because, it's not fun. But first of all, for the first statement, as you can see, I'm just rewriting the givens. G is the midpoint of line segment FH. We've also got line segment FE is congruent to line segment IH. And then the last one, line segment EG is congruent to line segment IG. So we've got 3 things here. Let me mark them on my triangles. First, for the midpoint, you're not going to write anything. Okay, you just can't. FE is congruent to IH. Okay, I can write that. One tick mark there, one tick mark there. And then it also says EG is congruent to IG. So EG, IG, there we go. Okay, now we look at the next statement. This time they give us the statement. They say FG is congruent to HG. They're saying the missing side we had earlier. Why would that be true? Well, the reason why is because of what was the given information. G is the midpoint. We know that midpoint cuts things in half, and so therefore the two sides have to be congruent. But what's the reason? What's the technical reason? If you look at your word bank, the correct answer is definition of midpoint. As a matter of fact, this is the only one with midpoint in the name, so it's a very good one to use whenever you see the word midpoint in the problem. And now we just have triangle EFG is congruent to triangle IHG. And for that, I look at what I have, and it looks like I have SSS. So it's going to be SSS theorem, side, side, side theorem, to prove they're congruent. And then the very last step, since we want to prove FGE, that's this angle right here, is congruent to HGI, that angle right here. Well, now, I use CPCTC. So the statement is going to be the proof statement. Angle FGE is congruent to angle HGI. And there we go. That's number 3. As you're going to be able to tell, these problems are going to get harder and harder as today goes on. They're not getting easier, I promise you that. But don't worry, I'm going to be holding our hand all the way through. And then when you get the chance to do it on your own with the homework, I definitely recommend taking it seriously and only looking at the answers when you absolutely need to. Because you're not getting any help if you're watching me solve it. Okay, any questions on number 3? Okay. Next we have number 4. Given angle WSV is congruent to UTV, WVS is congruent to UVT, and SW is congruent to TU, we want to prove that V down here is the midpoint of WU. So here's what I'm going to say. First, I see all the statements written out here. The reason is given. Just write given. That's always the first reason. Now I'm going to mark that on my triangles here. So I got to be careful because I can very easily mess up these angles if I'm not careful. So the first one is WSV. That's this angle right here. The next angle it's congruent to is UTV. That's this angle right here, so they're congruent. Okay, next is angle WVS. That's WVS right here. I'm going to put 2 tick marks. And then it says it's congruent to UVT. That's UVT right there. And then the very last thing I'm going to say is SW is congruent to TU. It looks like we already have a lot here actually. And if we look at the very next line, the next line says triangle SVW is congruent to TVU. Already we're at congruent. Why would they be congruent? Anyone have an idea? I'm asking the audience now.
Because side, side, side.
Not side, side, side. And why not? Because we don't know yet if these sides are congruent, and we also don't know if these sides are congruent. I don't know that yet. Would you like to take another guess?
They have the same lengths, right?
No, that's what I'm saying. It looks like they do, but I don't know if they do. And honestly, go ahead.
Is it the angle side angle theorem?
Now we're getting closer. So basically, you said angle side angle because we have 2 angles and a side. But if you look at the order here, it's angle here, side here. And that's what we know to be true. So in other words, even if it looks true, it doesn't mean it's true. Looks can be deceiving. As a matter of fact, I could say this side right here is, let's just make up a number. We could say it's 9. And this side is 9.1. Are they congruent? No. Can you tell that with the human eye? No. And plus, these aren't even drawn to scale anyway. So, go ahead.
Do they share common points with one another? Like each triangle shares, like, I don't know.
Yeah, I see what you're saying. No, I see what you're saying. Basically, you're kind of right. They do share common points, and ultimately that does lead them to be congruent, but that's why the proofs are there. Because a lot of times proofs are like, it feels like it's true, but I don't know if it's true or not. Because one day, when you're on your own, you're going to be only given the givens, and you're going to get the proof statement, and you're not even going to have any of this, and you're going to have to do it completely on your own. That's like the worst. And you're going to have to get there one day. And you will. You'll be stronger. You'll be better. But that's kind of the point, is like, it looks true. Like, V does look like the midpoint of W to me. But I don't know that yet, because you need to do these proofs. So anyways, the next line, why is it congruent? We just said it, AAS theorem. And now, because the triangles are congruent, we can say anything's congruent, including WV and VU. Why are they congruent? What's the reason? The reason is CPCTC. The step after the theorem is probably CPCTC. That's always a good bet. And then the very last one, V is the midpoint of WU. Why is that true? Well, it's true because of the definition of midpoint. And if you look back at your word bank, definition of midpoint is the only one with the word midpoint in it. And what definition of midpoint says is that if you have a midpoint, the two things are congruent. That's exactly what we have here. The two things are congruent, so therefore it's the midpoint. There you go. In other words, could you say V bisects line segment WU? Yes, you can say that as well. But that's not what they wanted us to prove, so I don't write that. But it's the same idea. Any questions for number 4? Okay. 2 more to go. We got number 5 and number 6. These are going to be the hardest ones, and we're going to be using a new property, a new reason that we have not talked about before, but it's going to show up twice in this one and the next one. So first, we already know the statements. We're going to say AD is congruent to CB, and we know that DC is congruent to line segment BA. And again, I'll show that on the graph. So it says AD is congruent to CB right there. And it says DC is congruent to BA right there. And again, they get 1 and 2 tick marks like that. Okay, so now this one's challenging because as you can see, there's a blank in the middle. Does anyone want to take a guess as to what the blank is in the middle?
Is it about right angles?
That's a good guess because it looks like it's a right angle. But again, just because it looks like a right angle doesn't make it a right angle. In other words, this could be 89 degrees, right? That's not a right angle because a right angle is 90. But how would you ever know? The only way you would know for sure if that was 90 degrees, it would have to say in the problem... Oh, 1 second, let me just finish. It would have to say in the problem that this is perpendicular. That's the only way you can say it's a right angle for sure. Okay, you can go ahead. What were you going to say?
So because of the sides, correct? Like it's like the theorem.
What theorem?
You know, like is it all sides theorem or is it?
Yeah, I see what you're saying. Yeah, so in other words, the reason why the triangles are congruent will be because of SSS. In other words, this third side, DB, is the missing one, and yes, it's congruent. And even though it looks obvious why it's congruent, you still need to put it as a statement and a reason. So the statement is DB is congruent to DB, which sounds ridiculous, but it is. And it's a necessary step here, okay? And the reason why, this is called the reflexive property. I know I brushed over it when we went over the word bank, and if you missed that part, you can see it in the video. I just brushed over it. But what the reflexive property is, when you use it, you use the reflexive property when you share a side. In other words, see how the two triangles here, I'll draw this one in blue and the other one in red. See how the two triangles share that side down the middle? Yeah, that's the reflexive property. Okay.
It's almost like a reflection.
Yes, you can think of it like that. Or as touching your toes. Although that's what is it called? When you can touch your toes, you have good, not reflexes, flexibility. Yeah, that's not all the same thing. Anyways, ignore my bad analogies. What's the proof statement that you want to prove BDA is congruent to DBC? Well, I already know that's going to be the last line because, well, it's always the last line is the proof statement. But what's the reason? Why are they congruent? just to be clear, BDA is this angle here, and we're saying it's congruent to DBC, which is this angle right here. How do I know they're congruent? The answer is CPCTC. Congruent parts of congruent triangles are congruent. Remember, congruent parts of congruent triangles are congruent is the thing that says everything is congruent. Like, for instance, AC is congruent, angle A is congruent to angle C, and the only angle missing is congruent to the only angle missing over here. All of that's true because of CPCTC. And by the way, if I asked, is this a right angle? Is A a right angle and is C a right angle? The answer is still no. I don't know if it's a right angle or not. Does it need to be? No, it doesn't matter, because that wasn't the point. The point was to prove the angles were congruent. I didn't care about the 90-degree angle, even if it looks like one. So with that being said, there's only one... Oh, go ahead.
Will all the reasons include CPCTC?
Today and on the homework, yes. In real life, no. Then why do I have CPCTC so often? It's because it's the most important reason. In other words, it shows up in... this is true. CPCTC, besides given, because given shows up in 100% of proofs, CPCTC shows up in like 90% of proofs you'll ever see. So that's why we're doing it. But good question. Next, number 6, the last one. Also, I messed up. This is not long enough. You need to make 2 more lines here. So in other words, 1, 2. Yeah, this one's going to be fun. It's the final boss. Oh, and by the way, next week we're basically doing the exact same thing, except we're going to be adding a few new reasons to our word bank, and then we're going to be doing this all over again, and you're really going to hate it next week. Like, I'm not going to lie. Next week sucks. It's the worst. But after we get through that, Lesson 7 and 8 are kind of fun, especially by comparison. So we just got to get through these next 2 weeks. You're not going to understand it when you go into the school year, but you are going to be better than your classmates, and you're going to learn it faster. And that's the goal, after all. So anyways, with the first statement, we already know I have to write this whole thing. PN is the perpendicular bisector. I'm just going to abbreviate that PB, perpendicular bisector of MO. And I'm going to say PN is the angle bisector, abbreviated AB, of angle MPO. And again, the reason why is that's given. So now, if I were to show that on my triangle, that looks like nothing. I know it means something to you because it says perpendicular, it says bisector, you know what that means. But right now, nothing is on my triangle, okay? So now, we have to use the reasons and the statements in order to answer this. So for instance, MN is congruent to ON. This is congruent to that. Can someone tell me why they're congruent based on the givens? Any ideas?
Is it definitional bisect?
You are correct, because what are we using? We're using PN as the perpendicular bisector. Remember, perpendicular bisector means 2 things. Number 1, perpendicular, obviously. Number 2, bisector. And definition of bisect is the correct reason. Now, the reason why you notice I paused just for a slight second is the very next reason says definition of angle bisector. And I think I forgot to put that in our word bank. But you get the idea. An angle bisector is basically the same thing as a bisector, except it works for angles. So with that being said, and looking at the givens again, who thinks they know what the statement will be? Go ahead.
Is it MNT is congruent to PNO?
You're very close. You're very close because, well, basically, you're not wrong, actually. I'm going to say you're not wrong. Oh, yeah. That's funny. Yes, okay, so you just... Oh, wow. PMPO. Yeah, you're right. Okay, so basically, I can't say you're wrong because you are right, but that's not the one I had in mind. So, again, you're not wrong, but that's funny. Okay, so Yeah, I'm just not going to write that because that's. I'm just going to go in the order I had planned. But yes, you're not wrong. And again, there's more than one way to do proofs. Like for instance, my angles that I said were congruent, I actually chose MPN and NPO, and the reason why is because of the definition of angle bisector.
Right.
So in other words, MPN is congruent to angle OPN, and that's just another angle you can choose. Now, as you can see, there's 1, 2, 3, 4 blanks here, and that would just be too mean for them all to be blanks. So I'm going to ask the audience, what do you want me to give you next? Would you like the statement or the reason? And you're going to give me the other one.
Statement.
Okay, I will give you the
Give
statement.
That's better.
The statement is going to be angle MNP and angle OPN are right angles. What is the reason? MNP and OPN, that means this angle here and this angle here are both right angles. Any ideas? The correct answer is, it is true because of the definition. Well, not definition. Sorry. Let me erase that.
All about right angles, correct?
It's about right angles, yes. Perpendicular lines form right angles. And how do I know they're perpendicular? It's because of the very first given statement. Okay, the next statement, if you use your intuition, the next statement is to actually say that the two things are congruent. MNP is congruent to OPN. Why is that true?
Oh, because they share a common point, P.
That is true. They share. Actually, no. I'm not talking about that angle. MNP is this angle right here, and ONP is this angle right here.
Oh yeah, N is the common point.
It doesn't matter that they have a common point. In other words, let me just give you an example. Let's say I just make up something. Okay, MNO. Would you say this angle is congruent to that angle? Definitely not. They're definitely different. So for that reason, just because they have a common point doesn't make them congruent. The correct answer is these are congruent because right angles are congruent. What the heck does that mean? Go ahead.
Did you mean ONP instead of OPN?
OPN. I'm a fool. Thank you for correcting me. Okay, yes, it's ONP. Thank you. Yeah, of course. Then no one gets the right answer if I give that. Yeah. And the reason why they're congruent is because right angles are congruent. Thank you for correcting me. I will now edit the video to make me seem smarter, and so they'll never know. Thanks to movie magic. Okay, now for the next one, I'm going to give you the reason, and you're going to give me the statement. The reason is AAS theorem. Any ideas? We know that that theorem is used to prove triangles are congruent. So,
Is it triangle MNP is congruent to triangle ONP?
you're exactly right. Thank you. And yep, that's true because of AAS. We have an angle, and we have a side for both. And then for the last one, what would we say? Remember, the proof statement is MP is congruent to OP. Go ahead.
So for this statement, we'd say line segment MP is congruent to line segment OP.
Exactly, yes. And what's the reason? Oh, come on, you know it. It's our favorite. Shows up every time. Okay. CPCTC. Congruent parts of congruent triangles are congruent. And before we end today, I just want to point out one more thing for this last one, because there's another thing we could have said. Instead of going the way we did it, you can also say PN is congruent to PN. In other words, this line segment is congruent to itself. And what would the reason for that be?
Reflexive property.
You're correct. The reflexive property. And so when you have that, well, now you have a whole list of choices. Like we used AAS, but if you have that side, you can use angle, side, angle if you want. You can use even side, angle, side if you want. And you can still use the original AAS. So when I say there's more than one right way to do this, I really mean it. So when you look at my homework answer choices and stuff, there's a chance that you may have discovered one that I didn't think of. Now, one thing you've got to be careful of, don't just assume you're right, okay? Because like we talked about in this example with the rectangle, just because it looks like something doesn't make it true. So if you do get a different answer than me and you still think you're right, why don't you just send me an email and I will check it for you and I can tell you if it's right or wrong. Because there's technically a lot of right answers for this homework. Any questions before I let you go? Okay. Well, then in that case, thank you all for joining me. Again, this is one of the worst ones of the summer. Next week's going to be even worse. So definitely, if I were you, let me just scroll back up to these reasons. You don't have to memorize all of these reasons, but if I were you, I would read through them all like 2 or 3 times and ask yourself when each one you would use them. And of course, if you missed this part in the recording, you can just rewatch the video. So thank you all for coming out today, and I will see you next week. Bye-bye.